Welcome.
The video explores the relationship between celestial alignments and terrestrial catastrophes. It details how conjunctions, which are not visual illusions of planets merging in the night sky. The forces highlights a specific theory, suggesting a 36-year cycle where the positioning of Saturn and Neptune coincides with massive geological events like the Krakatoa eruption and the Cascadia megaquake. The source asserts that a rare Saturn-Neptune conjunction and the peak of solar cycle 25 will converge in mid-2026 to exert extreme gravitational stress on Earth's crust. Using specialized metrics like the extra stress index, the text predicts high-intensity seismic events, volcanic eruptions in regions like Santorini and Mayon, and severe meteorological anomalies. Historical analogs from 1811 and 1917 are used to benchmark these projections, suggesting a repeat of catastrophic planetary upheaval. Ultimately, the material serves as a strategic briefing urging the hardening of global infrastructure against a forecasted window of unprecedented systemic risk. The creator argues that while tectonic strain provides a foundation for disasters, external forces like gravitational tidal torque and solar activity act as the final triggers for crustal failure. By analyzing historical data from 1917 and 1918, the source identifies predictable cycles and vector similarities that suggest a high risk of catastrophic events through 2026. Specific global danger zones, including the Pacific Rim and the New Madrid Fault, are highlighted as being under extreme stress due to these orbital influences. Ultimately, the material advocates for a predictive geological model that integrates satellite observations with complex planetary mathematics to anticipate future lithospheric shifts. Utilizing geodata AI Earth models, the source argues that planetary alignments, specifically the Saturn-Neptune conjunction, act as gravitational triggers for high-pressure geological systems. By analyzing historical precedents like the 1700 Cascadia subduction, the 1811 New Madrid ruptures, and the 1917 seismic clusters, the theory posits that the rapid separation of celestial bodies generates a critical vector resultant that ruptures the Earth's crust. Areas identified as high risk include the Cascadia subduction zone, the Mexican subduction boundary, and the Kamchatka Peninsula. Beyond earthquakes, the forecast warns of simultaneous solar flares and volcanic activity driven by these cosmic rhythms. Ultimately, the text serves as a technical warning to prepare global infrastructure for a mathematically predictable peak in terrestrial stress. The month of July 2026 represents a highly volatile and critical window within the overarching geodynamic forecasts, primarily because it sits at the culmination of the Saturn-Neptune separation phase. While the precise geometric minimum, the closest angular approach, of the Saturn-Neptune conjunction occurs earlier, on February 21st, 2026, the period running from March through July 2026 is defined by a steep ascent in the orbital data as the two gas giants rapidly separate. Deep inside analysis of historical baseline analogs, specifically the 1882 and 1917 single conjunctions, reveals that the maximum catastrophic activity, such as massive tectonic ruptures and Category 4 hurricanes, does not typically cluster on the exact day of the minimum, but rather during this period of maximum angular change and rapid separation. Within this macro-level gravitational separation phase, July 2026 features specific, localized planetary and celestial alignments that actuate. Earth's stress field 1. The Sun-Jupiter conjunction, the most significant exact planetary alignment logged for this month, is a Sun-Jupiter conjunction, which will reach its exact point on July 29, 2026, at 5:34 Universal Time Coordinated. Because Jupiter exerts a massive gravitational baseline on the inner solar system, its alignment with the Sun heavily influences the unified vector resultant, applying localized extra stress and contributing to the fluctuations in the Earth-Moon-Sun barycenter point 2. Transient Near-Earth Object, NEO. Perturbations. The July 2026 window is heavily saturated with transient kinetic and gravitational perturbations caused by a sequence of near-Earth objects making close approaches. The active celestial tracking registries log the following transits during this month. July 4th, a massive celestial body designated 523808, 2007 ML24, measuring between 360 meters and 800 meters in diameter, will transit near Earth at a relative velocity of 16.76 kilometers per second. The upcoming close approach of the near-Earth asteroid 523808, 2007 ML24, on July 4, 2026, at 1953 Universal Time Coordinated, represents a highly localized, transient gravitational event within our current geodynamic forecasting models. Evaluating this close approach event using the newly updated orbital mechanics and physical parameters reveals a comprehensive picture of its true kinetic and gravitational footprint on the Earth-Moon System. Point 1. Physical and orbital profile upgrades. The latest observational updates from the JPL Small Body Database drastically refine our understanding of this object. Reclassified with an absolute magnitude of h equals 19.35, the asteroid is physically much larger than previously assumed, possessing a verified diameter ranging from 360 to 800 meters. A deep insight analysis of this exact timeframe will be visualized within the presentation. The deck is designed to project the Earth's gravitational landscape by comparing the incoming planetary orbital mechanics against Julian date, JD, historical baselines from the 16th to 21st centuries. It will calculate the unified vector resultants and map where extra stress forces cross critical failure thresholds. Furthermore, as requested, the analysis will feature an extended forensic look at potential seismic ruptures greater than magnitude 5.0, complete with a correlated assessment of solar volatility and meteorological dissolution, all formatted over an executive bluish background while filtering out the raw XYZ coordinates. July 5th to 11th, multiple close transits, including 2026 MP3 and 2023 Y01 on July 5th, 2026 M01 on July 8th, 2026 MQ1 on July 10th, and 2007 AA2 on July 11. July 16 to 21. The convergence cluster, a rapid succession of transits, occurs mid-month, bringing 2026 MQ3, measuring 110 to 250 meters, on July 16th, followed immediately by 2025 PN7 on July 17th, 2025 MB90 on July 19th, and 2020 OM on July 21st. A massive megathrust failure is projected to strike the Alaska/Aleutian subduction zone, creating an extreme transoceanic tsunami risk across the entire Pacific Basin. July 20th to 21st, 2026. Aligning directly with the mid-month cluster of NEO perturbations, the models forecast a magnitude 7.2 repetition event along the Cocos Plate subduction zone, which threatens to trigger severe structural dissolution in the soft soil basins of central Mexico. The meteorological landscape transitions into a state of severe localized volatility, actuated by a critical coupling of lithospheric stress and atmospheric physics. The geocosmic threat logs project a massive magnitude 7.2 seismic rupture along the Cocos Plate subduction zone on July 20th to 21st, 2026. This severe crustal strain is expected to trigger a phenomenon known as piezoelectric atmospheric forcing, atmospheric ionization, and cloud anomalies. Under the extreme mechanical pressure of this subduction slip, quartz-rich basement rocks undergo massive compression, ionizing oxygen atoms and releasing electrical charges into the overlying air column. This electrical forcing is forecasted to generate two distinct atmospheric anomalies starting July 21st. Earthquake lights, EQL high altitude, luminous electrical glows resulting from localized oxygen ionization under peak shear stress. Radial cirrus cloud formations. The ionized column alters local condensation dynamics, seeding distinctive, high-altitude radial cirrus clouds that originate from the plate interface and align strictly along Earth's magnetic flux lines. Transient NEO contribution. This atmospheric and electrical feedback loop coincides directly with a transient gravitational perturbation on July 21st, 2026, at 6:16 Universal Time Coordinated, when the near-Earth object, 2020 OM, makes its closest approach to the Earth-Moon barycenter, nominal distance of 0.023320. This rapid transit acts as a high-frequency gravitational trigger, adding secondary stress to an already unstable atmospheric boundary layer.
Okay, so let's jump right in. You know, when we think about the biggest disasters in history, we usually see them as just random, right? Totally isolated events. But what if they're not? What if there's actually a hidden rhythm to all that chaos? Imagine for a second that the moments of greatest upheaval on Earth, we're talking massive earthquakes, the fall of entire empires, what if they're all connected to this huge, slow-moving clock up in the sky? So picture this, it's England, 1703. A storm of, almost unimaginable power hits. The famous writer Daniel Defoe was there, and he wrote about it like it was an all-out war waged by nature. This thing wasn't just a bit of bad weather, it was a monster event that completely reshaped the landscape and, honestly, it shattered the country's confidence. And that brings us to the big question we're looking at today: is all of this stuff purely random, or is there some kind of hidden timetable? The analysis we're digging into here proposes a pretty controversial, but you got to admit fascinating, idea that moments like that great storm aren't just one-offs. Instead, they might actually be part of a repeating, maybe even predictable, pattern. Okay, so to really get our heads around this theory, we've got to look up, way up. We're talking about a kind of celestial clock in the sky. It's slow-moving, ticking away every 36 years, and it's been doing that for as long as we've been looking at the stars. The key player here is something called a Saturn-Neptune conjunction. Basically, from where we're standing on Earth, it looks like the planets Saturn and Neptune line up in the sky. It happens about every 36 years. You can almost think of it like a cosmic reset button that gets pushed every 3.5 decades. And this isn't some new discovery, ancient astronomers were tracking this. But what's really wild is that this new analysis suggests that these alignments line up with some pretty profound events. This is where it gets really interesting. The core idea is that these 36-year alignments aren't just, a pretty sight in a telescope. The theory goes that they mark these hot spots in time for us down on Earth, periods of major upheaval and transformation, times when all the stuff we think is solid and permanent suddenly feels like it could just dissolve. So let me actually look at the timeline. Does the evidence hold up? Well, the source material lays out this really striking chronology of events. We're talking both stuff happening with the planet and stuff happening with people that seem to cluster right around these planetary meetups. Okay, so take the 1703 cycle. Right around that time, the Earth itself just shakes violently. The Cascadia earthquake hits, one of the biggest quakes in recorded history. It was so huge it sent what they call an orphan tsunami all the way across the Pacific to Japan. And then just a few years later, you get that monster storm we talked about, the one that basically crippled the Royal Navy. And the human cost? Just staggering. We're not just talking about a bad storm here, this was a full-blown national catastrophe. The death toll might have been as high as 30,000 people. Alright, let's fast forward about 100 years to the next cycle around 1809. What's going on then? Well, there's a massive mystery volcanic eruption that actually cools the entire planet. Then a series of earthquakes hit the American heartland, so powerful that people swore they saw the Mississippi River run backward. And get this, in what has to be a stunning coincidence, or maybe not, two guys who would completely change our world, Abraham Lincoln and Charles Darwin, were born on the very same day. Now let's jump to the 1917 conjunction. This one happened right in the middle of a perfect storm of human misery. You got World War I, the Russian Revolution, and the Spanish flu pandemic. It was a time of total chaos. And unbelievably, this period of human breakdown was mirrored by the planet itself, with devastating earthquakes in Italy and major volcanic eruptions and quakes back in the US. The sheer scale of all these events, both human and geological, is just immense, and they're all clustered together in time. Just one earthquake in Italy caused a level of devastation that was on par with that great storm from 200 years before. It's a lot. Okay, let's come to the most recent full cycle, the one that started in 1989. For many of us, this is living memory. It lines up with one of the most iconic moments of, well, dissolution in modern history, the fall of the Berlin Wall. And this whole theme of dissolving boundaries was just perfectly mirrored in nature. You had the perfect storm, which couldn't have a better name, and a volcanic eruption that literally showed us how easily nature can dissolve our most complex technologies when a jumbo jet flies through its ash cloud. Think about that perfect storm for a second. We're talking about rogue waves over 100 feet high. It's almost the perfect metaphor for the theme of this cycle, right? Just this untamable, chaotic power that dissolves all boundaries. But here's the thing, this pattern isn't just about disaster and chaos. that's only half the story. When you look a little closer, you start to see this consistent dual theme that pops up in every single cycle, and that core idea is this: dissolution and restructuring. It's a two-step process. For every system that breaks down, a new one seems to rise up and take its place. So while that great storm was raging in 1703, new institutions like Yale University were being born. While old ideas were being completely torn down in the 1880s, we were also starting the global temperature record, a totally new way to structure our understanding of the planet. It's like a dance between chaos and order, again and again. So to really get this, you have to understand the two symbolic forces at play here. Think of Saturn as the principle of structure, of order, of the hard, cold facts of reality. It's all about borders, governments, physical laws, things you can touch. Neptune, on the other hand, is the total opposite. It's dissolution, chaos, ideals, mystery, the formless. It's the fog that rolls in. So the theory goes, when these two energies come together, reality itself gets a little fluid. The solid structures of Saturn get challenged by the dissolving mist of Neptune. You know, we often think of history as this neat, orderly timeline, you know, A causes B, which causes C. But what if it's not a straight line at all? What if it's more like a rhythm, a recurring pulse of chaos and creation? To figure that out, we're going to look at history through a very, very different lens. I mean, really think about it. Are massive wars, devastating famines, and mind-blowing discoveries just random noise, a bunch of disconnected things happening all at once? Or just maybe, is there some kind of underlying pattern that connects them all? To explore that, let's go back in time to one particularly wild year. The year is 1846, and the world feels like it's coming apart at the seams while, at the very same time, it's taking these giant leaps into the future. It's a perfect storm of huge and seemingly unrelated events. So over in North America, a massive conflict just erupts. The Mexican-American War kicks off, and it's this huge geopolitical shakeup that is going to completely redraw the map of the continent. It really set the stage for decades of tension. Meanwhile, you jump across the Atlantic, and this just heartbreaking catastrophe is getting worse by the day. The Great Famine in Ireland, set off by this mysterious disease in the potato crop, is causing mass starvation. It's forcing millions of people to flee for their lives, an entire nation's social fabric is just dissolving. And at the same time, you've got astronomers, right? They're staring up into the night sky, and they make a discovery that just blows everyone's minds. A whole new planet, Neptune, is spotted for the very first time. This fundamentally expands our map of reality itself. And then get this, in the world of medicine, something happens that will forever change the human experience, the first successful public demonstration of ether anesthesia. This was a promise of an end to the absolute brutal agony of surgery. A war over land, a famine from an invisible blight, the discovery of a hidden world, and the conquest of pain, all happening in a single year. You can see them right here, just months apart. Are these events really, truly random, or are they all echoes of a single, powerful theme? It's a really cool idea, right? But does it actually hold up? Let's put this lens to the test. Let's look at some other conjunctions throughout history and see if we can spot that same theme: dissolution and restructuring. Okay, let's jump in our time machine and rewind all the way to the turn of the 18th century. Saturn and Neptune are meeting up again. And the pattern here is just stark. World War I is literally dissolving the great empires of Europe. Insane torrential rains are turning the Western Front into this nightmare of mud, a literal dissolution of solid ground. And then the Spanish flu, an invisible Neptunian plague that respects no borders and kills up to 100 million people, way more than the war itself. It was just a period of almost unimaginable chaos and dissolution. Okay, so armed with this new lens, let's go back to where we started, that chaotic year of 1846. Do those events seem a little less random now when you see them through this theme of dissolving the old to structure the new? Look at what else was brewing in the background. The Communist Manifesto was being written. Talk about a powerful, radical new ideology, a Neptunian ideal that called for the complete dissolution of all the existing class structures, the total overthrow of the established order, a blueprint for a whole new world. And remember that medical breakthrough we talked about? The timing here is just uncanny. So the first public demonstration of ether anesthesia happened on October 16th. This is the whole theme in a nutshell, isn't it? A literal dissolution of a fundamental part of human experience, pain. But it's happening inside a highly structured, Saturnian medical setting. An unseen force was finally being brought under control. And this is just incredible. It's the ultimate synchronicity. In the middle of this whole Saturn-Neptune cycle, the planet whose archetype represents mystery and the unseen is literally discovered. The formless is given form, the invisible is brought into the structured map of our reality. I mean, you couldn't make this up. Looking at history this way, you start to see these powerful connections that are so easy to miss otherwise. But what's the big takeaway from all this? What are we supposed to do with this? Okay, so the crucial point here is that this is not a crystal ball. This isn't about predicting the future. It's a tool, a lens for understanding the past. It helps us see a kind of thematic story in times of massive upheaval. It connects events that, on the surface, have absolutely nothing to do with each other. It just highlights these recurring moments where old realities, old structures, old boundaries simply dissolve to make way for the new. And that leaves us with a final thought, doesn't it? This cycle of dissolution and restructuring repeats about every 36 years. It really makes you wonder, as we move toward the next alignment, what long-standing structures in our own world, whether they're political or technological or social, might just be starting to dissolve into mist. 1836. Just think about that number for a second. That's how many people in the Netherlands died in a single night when the ocean just swallowed the coast. A truly staggering loss. But what if it wasn't just a random act of nature? What if that one horrific disaster was actually part of a much bigger cluster of global crises, all hitting around the same time? A kind of historical pulse, you know, where the world seems to just fall apart and then rebuild itself all at once? Okay, so let's jump right back to that number. It all kicks off around 1953, a year that saw this really startling pileup of intense global turmoil. So yeah, that number 1836, that was from the Netherlands. But the very same storm slammed the UK and Belgium. All told, more than 2,500 people were killed when the seawalls and dikes, the very structures built to protect them, were just completely overwhelmed. A terrible, once-in-a-century event. But here's where it gets weird, it wasn't an isolated event, not by a long shot. Just weeks earlier, on November 4, 1952, the Earth itself seemed to just crack open. A magnitude 9.0 earthquake, one of the absolute biggest of the entire 20th century, hit off the coast of Kamchatka, Russia. It was so powerful it sent a monster tsunami roaring across the entire Pacific. And sandwiched right between that megaquake and the killer flood, another crisis hit. This time, it was the air itself. In December 1952, London was choked by the Great Smog, a poisonous yellow-green fog of pollution that brought the city to a dead stop. The final toll is estimated to be as high as 12,000 dead. So when you lay it all out like this on a single timeline, it's kind of hard to ignore, right? A monster quake, a deadly smog, a biblical flood, all within about 90 days of each other. Are these just incredibly tragic coincidences, or is there something else going on here? Alright, let's get into it. Today we're going to talk about humanity's pretty incredible journey from basically just cowering before nature's nameless furies to actually measuring its most powerful forces. It's really a story about science, about survival, and about coming to terms with the awesome, sometimes terrifying power of the planet we live on. So I want you to just imagine for a second, it's the early 1800s. You've got no satellites, no radar, no warnings whatsoever. When a storm shows up on the horizon, it's a total, terrifying mystery. And back in 1806, one of those mysteries brought absolute devastation to the American coast. You see, before we could track these things, all you could really do was endure them. Your survival basically came down to luck and how strong your shelter was. And the Great Coastal Hurricane of 1806, well, it's a perfect, brutal example of that raw, chaotic experience. Just look at this path of destruction. For days, this thing just churned its way up the coast. It wasn't a storm so much as a multi-day siege. From Georgia all the way to North Carolina, it just left this trail of death and debris. It even played a part in world events, scattering warships during the Napoleonic Wars. And then you have the tragic end of the Rose in Bloom, a single ship, 23 lives lost. It's just a heartbreaking reminder of the storm's unforgiving power. And that's really the heart of it, isn't it? If you don't have a name for it, you can't track it, you can't warn people about it, you can't coordinate any kind of response. It's just the storm, a singular, monstrous event. This kind of helplessness was the reality for centuries, but it also set the stage for a really crucial leap forward in science. So now let's jump forward, way forward, nearly 150 years. We're going from a world of terrifying anonymity to a moment where we started to put some order on the chaos. Because in 1953, the way we deal with hurricanes was about to change forever. You know, naming a storm isn't just some quirky tradition, it is a vital communication tool. Just think about it. How would you issue warnings for the storm off the coast if there are 3 storms off the coast? Giving each one a distinct human name makes tracking, reporting, and getting those public warnings out infinitely clearer and, frankly, way more effective. And this was the year it all became official policy. I mean, before this, storms were sometimes named informally, but in '53, the US Weather Bureau adopted a formal, alphabetized list of female names. It seems like a simple idea now, but it had these profound consequences for disaster preparedness. And this was it. This was that very first list, and right at the top, Alice. She was the very first storm to be officially given a female name in the Atlantic. This simple list right here represents the beginning of a system that has, no question, saved countless lives by turning a formless threat into a known enemy. Okay, so we learned to name the Fury from the sky, which gave us the power of prediction. But what about a force that you can't predict, a force that doesn't form on the horizon, but is just constantly churning right underneath our feet? This is where our story takes a really dramatic turn away from the atmosphere and down into the very crust of the Earth. Whoa, take a look at that number, over 20. That's how many major earthquakes shook our planet in one single month, January of 1995. This one stat just completely reframes the whole idea of a threat. See, storms are seasonal, they come and go. Geology is a constant, relentless condition. And that's the fundamental difference right there. We can watch a hurricane form, we can track its path, we can see it dissipate. But the forces that drive earthquakes, they are relentless. Those tectonic plates are always shifting, always building up stress that can be released at any moment, anywhere in the world. The power is always there, just waiting. So we've established it's a constant risk. But what about the scale of the power? Now we can measure these events with incredible precision. So let me just take a look at some of the biggest earthquakes ever recorded. This table shows you the kind of energy we're talking about. Each whole number you go up in magnitude represents a massive leap in power. These aren't just tremors, these are events that literally reshape landscapes and release the energy of thousands of nuclear bombs. From Alaska to Tibet, you can see the global reach of the Earth's might. This side-by-side comparison really puts it all into perspective. With a hurricane, our science gives us this amazing gift of time. We can watch it develop, we can track its path, we can get people out of harm's way. With an earthquake, there is no warning. The threat is constant and the impact is instantaneous. Science lets us build safer buildings and create response plans, but it can't give us a forecast. It's a completely different kind of challenge. So after all this, what does this whole journey, from an unnamed storm in 1806 to a precisely measured earthquake today, tell us? What have we learned, and what's the ultimate takeaway here? This timeline really shows an incredible arc of human ingenuity. I mean, we went from being purely reactive victims of nature's whims to proactively observing, naming, tracking, and measuring its most powerful forces. It's one of the great stories of scientific achievement, really. But, and this is a big but, that achievement comes with a heavy dose of humility. This quote just captures the paradox perfectly. We understand these forces better than we ever have before, we can plot every fault line and model every potential storm path, and yet, when the Earth decides to shake or the wind decides to blow, we are still fundamentally at their mercy. And this is the question we're left with, isn't it? We have come so far, from terror to comprehension, from mystery to measurement. Our science is remarkable. But as we stand here with all of our knowledge, are we masters of our world, or are we just more informed subjects of its incredible, untamable power? It's something to think about. Well, that cycle that started back in 1989 with the fall of the Berlin Wall, it's ending. The next Saturn-Neptune conjunction is happening on February 20th, 2026. So we're less than 2 years away from the start of what this historical pattern suggests is going to be a profoundly new 36-year chapter. Looking at the historical record, it suggests these transitions, they're not exactly comfortable, but they are profoundly transformative. This analysis isn't making any specific predictions, of course, but it does leave us with a pretty provocative final thought. It feels like we are standing right at the end of one long chapter and at the very first fiery sentence of the next one. So the question is, what story is it going to tell? Around 1809, the theme for this period couldn't be clearer: the literal and figurative shaking of the entire world's foundations. The geological chaos during these years was completely off the charts. We're talking a series of monster earthquakes right in the heart of North America, preceded by a colossal, climate-altering volcanic eruption that nobody even knew happened for 200 years. And that was followed by the eruption of Mount Tambora, the single largest eruption in all of recorded history, which literally plunged the planet into a volcanic winter. And the scale of these events is just mind-boggling. I mean, think about it, earthquakes so powerful they made the Mississippi River flow backwards, a volcanic eruption so big it blotted out the sun, leading to a year without a summer that triggered massive famines across the entire globe. These events didn't just challenge structures, they completely rewrote the landscape itself. So after looking at these three distinct, chaotic moments in history, what's the big takeaway here? What does looking at things through this cyclical lens actually get us? Well, it offers a totally different way of seeing the past. Instead of that simple, straight arrow of cause and effect we learn in school, this model suggests history acts more like a wave. You get these intense pulses of disruption across geology, politics, society all at once, followed by periods of relative calm where we rebuild. And let's be really clear about something, this isn't about astrology or fortune-telling. The point is not to predict the next earthquake, it's about pattern recognition. It's a tool for seeing the past in a new light, as a recurring rhythm where our most solid structures are tested, dissolved, and then reformed. Which leaves us with a pretty deep question, doesn't it? If these intense pulses of chaos and collapse are an inevitable feature of history, how do we prepare for them? How do we build societies, systems, and defenses that are not just strong, but flexible enough to endure the next inevitable storm?
Welcome to The Explainer. Today, we're going to explore humanity's long and, let's be honest, terrifying history with natural disasters. And we're going to look at the deep-seated need we seem to have to record them. It is a journey that takes us from personal horror to planetary data. But first, let's talk about those moments when planets seem to line up, getting incredibly close in the night sky. We're going to break down what's really going on up there. I bet you've seen it yourself. You're looking up one night, and you see two super bright points of light way closer than they should be, and you think, wait a second, those aren't stars. That feeling of awe is exactly what we're diving into. It's a moment people have been experiencing for forever. Our game plan is to start with the sheer beauty of the celestial dance, get into the science of what conjunction actually is, check out the different planets and objects involved, look at some of the most mind-blowing alignments, and then zoom out for the big cosmic picture. It really does look like a perfectly choreographed dance, doesn't it? You can watch night after night as two planets slowly drift closer and closer, almost like they're waltzing, until they nearly merge into one brilliant beacon of light. It feels totally magical. But as magical as it seems, it's not magic at all. It is something way cooler: orbital mechanics. It's the beautiful, predictable clockwork motion of the planets, including our own Earth, orbiting the Sun. The official term for one of these cosmic meetups is an astronomical conjunction. While that sounds a bit technical with textbook terms like right ascension and ecliptic longitude, you can ignore the jargon. The only phrase you really need to focus on is, as observed from Earth. That is the absolute key, because a conjunction is entirely a trick of perspective. It's a line of sight event. The planets aren't actually getting close to each other at all. They just happen to line up perfectly from where we're standing. Picture it this way. You're on Earth, you look up and you see the moon. Now imagine that way out in deep space. The giant planet Jupiter happens to pass into that exact same line of sight. From your point of view, they look like they're right next to each other. What's wild about the illusion is that the moon is roughly 240,000 miles away, but Jupiter is over 400 million miles away. They aren't even in the same celestial zip code, but for a brief moment from our backyards, they look like they could touch. This celestial lineup can happen with all sorts of different dance partners. Moon and planet, the most common pairings, where our fast-moving moon cozies up with a bright planet like Venus. Planet and planet, classic planetary pairings, like when Mercury and Mars pass each other. Solar conjunctions, alignments that involve our sun. We need to draw a clear line between these things. An apparent conjunction is the beautiful one we see at night, when two objects look close together. A solar conjunction, on the other hand, is when a planet lines up directly behind the sun from our perspective, making it completely invisible, lost in the sun's blinding glare. To measure this closeness, astronomers use angular separation, the apparent gap between two objects in the sky. To give you some perspective, the full moon is about half a degree, 0.5 degrees, wide. On August 22nd, 2032, a predicted conjunction between Mercury and Mars will bring them to a staggering angular separation of just 0.376 degrees. An alignment this close is incredibly rare. You won't be able to tell them apart with the naked eye. They will just look like one single, blazing star. When you dig through historical data, you find other spectacular moments, like the incredibly close pass between Mercury and Neptune in 1945, or the upcoming 2034 alignment, where Venus and Mars will get close in the width of the full moon. It's amazing to see this intricate dance mapped out across time. How do we record disasters today? The approach has shifted dramatically from historical storytelling to modern data logging, from feeling the event to measuring it. Nowadays, we catalog catastrophes in spreadsheets and databases. Names that echo through history, Vesuvius, Krakatoa, are now organized by date, location, and quantified impact, like mapping the deadly pyroclastic flows, superheated, fast-moving clouds of ash and gas of Mount Pelee. It's a fiery ledger of our planet's most violent moments. This captures a massive cultural pivot. On one side, historical writers like Daniel Defoe focus on eyewitness stories and a hand of providence. On the other side, modern science zeroes in on precise data, death tolls, economic costs, and geological scales like the Volcanic Explosivity Index, VI. We pivoted from documenting onto performing analysis because that analysis lets us build safer cities, write better policies, and save lives. This systematic recording is part of a coordinated global effort. Our universal drive to understand the world now has a global digital memory. We have detailed logs of Atlantic hurricanes going back centuries, tracking dates, locations, and even odd historical footnotes, like the 1766 hurricane that financially ruined the family of Napoleon's future wife, Josephine. Our gaze even extends beyond our atmosphere. We track threats from 93 million miles away, documenting huge solar storms and how they impact our technology, from setting telegraph systems on fire in 1859 to knocking out entire modern power grids. Organizations like the USGS and NOAA maintain these vast databases, creating a global ledger of our planet's power to understand a rhythm of risk on a planetary scale. But why do we compile these grim catalogs of destruction? The reasons are both scientific and deeply human. It is about survival and recognizing patterns to prepare for future, but it is also about memory, honoring those lost and finding meaning in a world filled with forces greater than ourselves. The mission of a modern scientist is not all that different from Daniel Defoe's. His goal was to convey a memory to the ages to come. Today we use data instead of poetry, but the core mission remains the same. This brings us to a compelling question. Are the great disasters of history truly random, or are they connected by a hidden rhythm in the cosmos? Our source material suggests a mind-bending idea. A 36-year cycle of Saturn-Neptune planetary alignments linked to major terrestrial disasters. Let's look at how the history blocks out across this 36-year drumbeat. 1700, Cascadia megathrust quake, falling right in the 1699 to 1703 planetary conjunction window. A monster magnitude 9.0 quake struck North America. This data point solved a massive geological mystery. Scientists use historical Japanese records of an orphan tsunami a giant wave with no local earthquake. In 1700, it traced the wave back to this exact North American fault. 1737, Kamchatka quake, exactly one cycle later. During the 1735 to 1739 window, Russia's Kamchatka Peninsula was slammed by a magnitude 9.0 earthquake. The resulting tsunami produced waves reported up to 60 meters high, the height of a 20-story building. 1773, global activity window the next cycle, 1771 to 1775, saw global tectonic activity. Japan was devastated by the Great Yaima Tsunami in 1771, while halfway across the world, the Santorini volcano erupted under the sea in Greece. 1883, the destruction of Krakatoa moving forward. The 1880 to 1884 window hosted a cataclysmic eruption of Krakatoa in August 1883. Notably, the 1882 planetary conjunction was the tightest alignment of Saturn and Neptune ever recorded from Earth. A year later, the planet experienced its most violent volcanic eruption, spawning 100-foot waves and killing over 36,000 people. 1952, Kamchatka repeats centered around the 1953 window. Kamchatka was struck again on November 4, 1952, by another magnitude 9.0 earthquake and a massive Pacific-wide tsunami. 1989, the Berlin Wall and Mount Pinatubo. In November 1989, the Berlin Wall crumbled. Less than 2 years later, in June 1991, Mount Pinatubo unleashed the second largest volcanic eruption of the 20th century, altering global climates and dropping world temperatures by half a degree. A concrete political barrier, Saturn, dissolved at the same time a solid mountain dissolved into a chaotic veil of ash, Neptune. Is this a genuine cosmic rhythm, or is it just our human brains desperately finding patterns in the chaos? Mainstream science views these events through purely terrestrial models like Coulomb stress transfer, which explains earthquakes as a physical chain reaction of mechanical stress moving down a fault line like falling dominoes. Using these metrics, seismologists successfully forecast a massive rupture along the Kamchatka subduction zone. Mainstream science also utilizes the Brownian passage time, BPT model. This model states that tectonic stress builds steadily, but random physical noise within the Earth's crust makes exact timing fundamentally unpredictable. Less like a clock, and more like a leaky faucet where you know a drip is coming but cannot predict the exact second it falls. This sets up a fascinating clash between a tantalizing cosmic pattern and the scientific embrace of randomness. The next exact conjunction of Saturn and Neptune occurs on February 20th, 2026. Astrologically, it lands at the very beginning of the zodiac, signaling powerful, world-changing new beginnings. Historical analysis points to potential themes, challenges to global power structures, the redefinition of national borders, and the birth of a new global paradigm. If history truly does have a hidden beat, we are about to find out what song the universe is playing next.
Welcome to The Explainer. Today, we're going to explore humanity's long and, let's be honest, terrifying history with natural disasters. And we're going to look at this deep-seated need we seem to have to record them, a journey that takes us from personal horror to, well, planetary data. All right, let's dive right in. Our story really kicks off more than 300 years ago with this incredibly powerful statement. It's all about the duty of a historian, right? It's basically a declaration that what you write down, what you record, carries this huge responsibility, not just for right now, but for everyone who comes after. Okay, picture this. It's October 17th, 1989, an absolutely perfect fall day in the San Francisco Bay Area. We've got over 62,000 fans jammed in Candlestick Park, and literally millions more watching on TV. Why? It's the Bay Bridge World Series, the Oakland A's versus the San Francisco Giants, a historic match. But then at 5:04 p.m., the ground itself starts to heave, and the biggest game of the year suddenly becomes a tiny footnote to history. And this is the exact moment it all began. You're listening to the legendary sportscaster Al Michaels, live on national television. And right in the middle of his sentence, the broadcast booth starts shaking violently. If you were watching, you saw the TV picture just flicker, and then static. The feed went completely dead for 15 absolutely terrifying seconds. A massive earthquake was ripping through the region, and the entire world had a front row seat for the second it started. But here's the incredible, mind-bending paradox at the heart of this whole story. Even though the quake caused so much tragedy, the very thing that had the world's attention, that World Series game, actually stopped a much worse catastrophe from happening. And that leads us to this unbelievable question. How on earth did a baseball game, of all things, end up saving the Bay Area on its darkest day? To really understand what happened at 5-0 for that evening, we have to look deep underground. You see, the incredible beauty of the Bay Area is sitting right on top of a restless, colossal geologic power source. And for over 80 years, it had been silently, steadily building up pressure. And this is the prime mover behind it all, the San Andreas Fault. It's this 800-mile-long scar running right through California. And it's where two gigantic tectonic plates, the Pacific and North American plates, are constantly grinding past each other. Now, most of the time, they're stuck. They're locked together, just building up more and more strain. And when that strain finally lets go, well, that's when you get an earthquake. So this brings us to a really fascinating and kind of scary concept called the seismic gap. See, after that monster 1906 San Francisco earthquake, the part of the fault down under the Santa Cruz Mountains just went quiet, ominously quiet. And seismologists knew this was not a good thing. It meant that section was locked tight, basically winding up like a giant coiled spring, just storing up energy. They even gave it a name, the Loma Prieta segment. And you can just see the buildup happening over time. Right here, after all those quiet decades, the fault started to stir. First, a 5.3 magnitude quake in June of '88. Then, an even stronger 5.4 quake in August of '89, just 2 months before the big one. These were foreshocks, little warnings, really, that the massive spring was getting ready to snap. And then, at 5:04 p.m. on October 17th, it happened. That coiled spring finally snapped. All that energy, all that pressure that had been building since 1906 was unleashed in just a handful of seconds. The raw power was just staggering. The quake clocked in at a 6.9 on the moment magnitude scale. That's the modern scale, the one that measures the total energy an earthquake releases. The rupture started 12 miles below the surface, and it sent these incredible shock waves out in every direction, shaking the entire Bay Area from Monterey all the way up past San Francisco. Just 15 seconds. That's how long the most violent shaking lasted. Think about that. In less time than it takes to tie your shoes, entire freeway sections came crashing down. Buildings were literally jolted off their foundations, and the landscape of the Bay Area was just changed forever. But here's the thing. The damage wasn't even close to being uniform. So why did some places get totally flattened, while other nearby spots were okay? The answer is all about geology. If your house was on solid bedrock, you felt less intense shaking. But if you were in an area built on artificial landfill or soft bay mud, well, that was a whole different story. That soft ground acted like a bowl of jello, amplifying the waves. And in some spots, the ground itself failed in this wild process called liquefaction, where solid, water-saturated dirt basically turns into a liquid. And this difference in geology, well, it led to some absolutely catastrophic failures that became the defining, tragic images of the Loma Prieta earthquake. Two locations in particular really tell the story of this disaster. First up, San Francisco's Marina District. And talk about a cruel twist of irony. This whole neighborhood was built on landfill that was partly made of rubble from the 1906 earthquake. So when the shaking started, that ground just liquefied. You had these soft-story buildings with big, open garages on the ground floor that just pancaked down onto the cars below. And to make matters worse, gas lines broke, sparking these massive fires that just raged through the night. And then there was the Cypress Street Viaduct in Oakland, a double-decker freeway. Now, it was built on old marshland, so the shaking was amplified there too. Its support columns were built to an older code. They were strong enough to hold up cars, sure, But they didn't have the flexible steel inside needed to sway with the quake's motion. So they just shattered, and the whole top deck came crashing down onto the bottom deck, trapping commuters inside. And this was the devastating human cost. All told, 63 people lost their lives. But just look at where those tragedies happened. The data here tells a brutal story. A staggering 42 of those deaths, that's 67% of the total, happened in that one spot, in the collapse of the Cyprus Viaduct. Which brings us right back to our central question. At 4 minutes past 5 on a Tuesday afternoon, the Cyprus Viaduct and every other freeway in the Bay Area should have been bumper to bumper with rush hour traffic. But they weren't. Why? Because of the World Series. People had left work early. They'd gone home. They were at parties to watch the game. And because of that, traffic was unusually light. This single twist of fate, this baseball game, without a doubt saved hundreds, maybe even thousands of lives that in the days, months, and years that followed. The Bay Area didn't just rebuild, it was fundamentally transformed. The earthquake was a massive wake-up call that completely reshaped the region's infrastructure, and honestly, its whole attitude about living on a fault line. The total price tag for property damage was estimated at $6 billion. To put that in perspective, that's over $15 billion in today's money. At the time, it was one of the most expensive natural disasters in the history of the United States. And this led to some of the biggest, most permanent changes to the Bay Area's landscape. Major freeways that got damaged, they weren't even repaired, they were torn down completely. The quake gave cities like San Francisco and Oakland the political push they needed to get rid of these ugly, elevated freeways that had cut through neighborhoods for decades, opening up beautiful waterfronts and creating brand new boulevards. Now, the Bay Bridge shut down for a whole month for repairs. Public transit suddenly became the region's lifeline. Daily ridership on the BART train system shot up by over 50%. Hundreds of thousands of commuters had to find a new way to get around. And it became this huge, unplanned experiment in mass transit. But maybe the most important legacy of all is the one you can't always see. The earthquake laid bare just how vulnerable the region's infrastructure was. It kicked off this massive multi-decade, multi-billion-dollar effort to seismically retrofit every single major bridge, overpass, and public utility to withstand the big one that everyone knows is coming. Which leaves us with this final thought. The lessons from Loma Prieta were learned at a terrible price. But they forced the Bay Area to become a world leader in earthquake engineering and preparedness. The region is, without a doubt, stronger and safer than it was in 1989. But the San Andreas Fault is still down there, still building up stress, reminding everyone that the question isn't if the next big one will hit, but when, over 200 years ago, a series of earthquakes shook the American heartland so violently that they actually made the Mississippi River run backward. It's an incredible story that's been mostly forgotten, but the ground deep beneath the central U.S. definitely hasn't. So let's get into it. This is the story of America's sleeping giant. Just try to imagine this for a second. You're asleep on a boat floating down the Mississippi, and you're jolted awake by that. That's the real experience of a naturalist named John Bradbury, way back in 1811. And he wasn't caught in some freak storm. He was caught in the middle of a geological event of historic proportions, 0.2:00 in the morning. That's when the shaking began for the settlers scattered across the American frontier. This was no small tremor. This was the beginning of an absolute nightmare, a winter of pure terror. And the thing is, this wasn't just a one-and-done event. Not even close. What we're talking about is a relentless, terrifying sequence of quakes and aftershocks that just kept the ground moving for months on end. Okay, so just look at this timeline. The first big one hits just after 2 a.m. in total darkness. Then only 6 hours later, right as the sun's coming up, bam, another massive one hits. Then another monster quake in January. And finally, the catastrophic one in early February. This wasn't just an earthquake. It was a sustained assault by the Earth itself. So, while John Bradbury was out on the river, Eliza Bryan was in the town of New Madrid. And her account, well, it paints a picture of just pure chaos on land. You've got people screaming and running everywhere, with no idea what to do or where to go. Animals are going crazy, trees are cracking and falling down. The world was literally breaking apart all around them. That last major shock on February 7th, that was the knockout punch. It completely leveled the town of New Madrid, the place that gives these quakes their name. And its power was so immense that it was toppling chimneys, hundreds of miles away in St. Louis. The damage to the towns was one thing, but what these earthquakes did to the actual landscape is just almost impossible to believe. The world was literally remade in a matter of months. And here's maybe the most famous and, frankly, the wildest effect of all, also described by Eliza Bryan. The Mississippi River flowed backward. No, that's not a hallucination. The quake physically shoved the riverbed upward with so much force that it created temporary waterfalls and sent massive waves flowing upstream, actually reversing the flow of America's mightiest river. The quakes literally redrew the map. Over in Tennessee, the ground just dropped 20 feet, and the Mississippi rushed in to form what we now call Reelfoot Lake, an entire lake created in an instant. Islands in the river, they just vanished. Farmland was completely ruined when the shaking turned solid ground into a liquid mush, forcing sand and water to erupt from below. It was a complete and permanent transformation of the land. All of this just begs a huge question. When we think of massive earthquakes, we think of California, we think of Japan, but Missouri, how could one of the most powerful seismic events in history happen right in the middle of a continent, thousands of miles from any tectonic plate boundary? Well, to understand why, you have to get a sense of the scale. The shaking from New Madrid was felt over an area of about 1 million square miles. Compare that to the famous 1906 San Francisco quake, which was felt over about 6,200 square miles. The reason for the massive difference? The Earth's crust in the central U.S. is older and colder, so it transmits seismic energy incredibly well. It basically rings like a giant bell. And the culprit behind it all is a deep, hidden weakness called the Reelfoot Rift. So, about 750 million years ago, the continent actually tried to rip itself apart right here. It failed, but it left behind a deep scar, a whole network of faults. And it's that ancient wound that ruptured so violently in 1811 that, make no mistake, this rift is not dormant. Since scientists installed modern seismographs back in 1974, they've detected over 4,000 earthquakes in this zone. Now, the vast majority are way too small to feel, but they're a constant reminder that the fault system is active and that it's still building up stress at us. This brings us from history right to the present day, because the very same forces that caused the terror of 1811 are still at work deep underground, right now as we speak. So what's the risk today? Well, according to the U.S. Geological Survey, there's a 25% to 40% chance of a magnitude 6.0 or greater earthquake hitting this region within the next 50 years. That is a significant probability of a very, very damaging event happening in our lifetimes. And what would that actually look like today? FEMA does not mince words on this. They've stated that because the region isn't built to the same seismic standards as, say, California, a major quake there could cause, and I quote, the highest economic losses due to a natural disaster in the United States. The damage would be, in their words, widespread and catastrophic. So the story of New Madrid isn't just history, it's a warning. It's a powerful reminder that some of the biggest dangers are the ones we can't even see, buried deep beneath our feet, just waiting for the pressure to build. So the question isn't really if it will happen again, it's when, there are some forces in the world that are just so immense, so incredibly powerful. They kind of remind us of our place in the universe. They shape our world, and they shape our history. Today we're going to dive into the stories of one of those forces, the North American blizzard. But that brings up a really big question, right? When you're faced with something that massive, how do you even begin to wrap your head around it? How do we measure it, record it, and tell its story? That's exactly what we're going to get into. Let's start with our first chronicle from an era of what they called white hurricanes. That name says it all, doesn't it? This isn't just a snowstorm. It's about pure, raw, earthly fury, all recorded long before we had fancy weather satellites. Check out this timeline of some of the heavy hitters from back then. And notice the year 1888. What a brutal year. 2 monster blizzards, just months apart. First, the schoolhouse blizzard hit the plains so fast it trapped kids in their schools. Then, the Great White Hurricane literally buried the entire Northeast. The thing about these storms was just how sudden and totally devastating they were on a local level. Let's zoom in on one of these. The Knickerbocker Storm in 1922. Now, this one wasn't a sprawling giant, but what it did to Washington, D.C. was just profound. It dropped this incredibly heavy wet snow, and that's the dangerous stuff. It's like concrete falling from the sky. And this is the real human cost, boiled down to one single heartbreaking number: 98. That's how many people died when the roof of the Knickerbocker Theater just gave way under all that weight. One building, one failure, and a tragedy that would define the entire storm. Now listen to this quote about that other storm from 1888. Snow drifts over 50 feet. I mean, seriously, just try to picture that. That's not a snow day, that's not an inconvenience, that is civilization grinding to a dead halt in the face of nature's power. Okay, so let's jump forward to the modern era. The story of blizzards really starts to change here because with our modern world, with all our interconnected highways and supply chains, the big story isn't just about local damage anymore, it's about massive, widespread disruption.
Let's examine our latest executive hazard assessment for the critical 10-day window in mid-2026. By integrating astrodynamics with seismic and volcanic forecasting, we are tracking Earth's gravitational landscape with unprecedented precision. We've identified elevated stress levels using key parameters like the extra stress index and vector resultants. This simulation is vital for identifying meteorological anomalies before they escalate. Our focus remains on proactive mitigation, ensuring we stay ahead of potential geological and atmospheric disruptions worldwide.
In 2026, an unprecedented convergence of cosmic cycles will threaten global stability. The Saturn-Neptune conjunction generates extreme stress on Earth's lithosphere, echoing historical catastrophes. Simultaneously, the peak of solar cycle 25 will unleash solar flares that destabilize our geomagnetic shield. This combined pressure will buckle the jet stream, triggering abrupt atmospheric dissolution and severe meteorological anomalies. We are entering a period where our planet's natural defenses face an existential challenge from these overlapping astronomical triggers.
As we progress into solar cycle 25, we are facing a period of intense atmospheric and tectonic upheaval. We anticipate multiple extreme solar flares that will compromise our magnetic shielding, allowing cosmic rays to destabilize the jet stream and trigger abrupt weather shifts. This phenomenon, known as the dissolution effect, merges geomagnetic instability with tectonic outgassing. The result is a highly volatile meteorological environment, significantly increasing the risk of anomalous cyclonic events and planetary scale instability.
As solar cycle 25 approaches its peak, we are witnessing a dangerous convergence of space weather and terrestrial hazards. Intense solar flares, driven by unique planetary alignments, are pushing global temperatures significantly higher. This thermal shift is fueling extreme thunderstorms across the Pacific Rim and Southeast Asia. Most critically, this increased rainfall creates a compounding threat, as heavy downpours trigger devastating volcanic lahars. We must prepare for these interconnected disasters as this solar activity intensifies.
History shows that Saturn-Neptune conjunctions often precede catastrophic global shifts. Currently, the intersection of planetary vectors and solar cycle 25's peak magnetic instability is generating extreme stress on our tectonic boundaries. This leads to a high-confidence forecast. During the critical window of July 10th to 24th, 2026, we anticipate concentrated M5.0 plus megathrust events and significant atmospheric dissolution. This data represents a period of unprecedented risk that demands our immediate attention. Notice the chilling precision here. The 2026 astrodynamics mirror the sharp V-shaped angular minimums of our 1917 baseline with near-perfect accuracy. This convergence suggests more than just mathematical symmetry. It's a predictive blueprint. Based on this correlation, we anticipate high-intensity natural disasters during the upcoming vector separation phase. We are effectively looking at a repeat of the 1917 analog, signaling a period of catastrophic global events that demand our immediate attention and preparation. We can now confirm that the V-trough alignments of the 20th century establish the exact geometry for our current trajectory. Historically, these steep angular separations have been harbingers of global instability. In 1917, this pattern triggered major quakes and weather anomalies, while the 1952 Kamchatka event produced a massive M9.0 earthquake. Today, The 2026 trajectory directly mirrors these high-risk cycles, indicating we are entering a critical window for severe seismic and planetary upheaval. By applying deep vector forensics, we can now benchmark the 2026 threat against precise historical analogs. By mapping planetary coordinates across centuries, we've identified geometric echoes of the upcoming Saturn-Neptune conjunction. Crucially, history proves that peak volatility rarely occurs during the alignment itself. Instead, the greatest danger emerges during the separation phase, the period of rapid angular divergence immediately following. This pattern tells us exactly when to expect the most significant impacts. As we approach late 2026, solar cycle 25 enters a volatile phase, significantly weakening our magnetic shielding. This allows deep space cosmic rays to flood the atmosphere, triggering massive ionization and global cloud seeding. This disruption ripples downward, violently destabilizing the jet stream and fracturing the polar vortex. The result is a dangerous meteorological convergence, a synchronized era of flash freezes, devastating floods, and extreme seismic activity that will fundamentally redefine our global climate reality. We are currently monitoring a dangerous intersection between declining solar cycles and surging weather volatility. As we approach July 2026, our projections indicate a high-risk window for severe environmental events. We expect a warmer, wetter atmosphere to trigger major jet stream anomalies and intense cyclonic activity. Crucially, these atmospheric shifts will cluster precisely around forecasted seismic stress periods. We must prepare for a period of unprecedented meteorological instability that extends well through the end of the decade. The 2026 Saturn-Neptune conjunction is a profound physical mechanism, driving a systemic convergence across astrodynamics, geodynamics, and thermodynamics. These planetary vectors do more than warp the Earth's crust, triggering events like the July X-peak earthquake sequence. They simultaneously disrupt the solar magnetic field. Therefore, tectonic megathrusts and extreme atmospheric dissolution are not isolated anomalies, but parallel symptoms of the same celestial mechanics. This tidal torque reveals how cosmic forces dictate our planet's most volatile shifts.
To understand the forces shaping our world, we must look beyond our atmosphere. When outer planets align, their combined gravitational pull creates a unique angular minimum known as a V-trough. This celestial geometry dictates terrestrial tension through the planetary engine. As Earth enters the separation phase of this alignment, sudden shifts in gravitational vectors exert extreme shear force, what we call extra stress, directly onto our tectonic fault lines, intensifying global geological activity.
To understand global tectonic shifts, we must look beyond our atmosphere. Our vector resultant engine translates raw celestial mechanics from deep space, specifically the Sun, Moon, and Jupiter, into precise surface stress mapping. By synthesizing centrifugal pull and tidal torque, we calculate the vector resultant. This process transforms spatial data into the extra stress index, identifying localized gravitational hotspots across the globe. It's a revolutionary leap in predicting planetary scale instability. Our 3D projection model allows us to map celestial mechanics with unprecedented precision. By tracing gravitational vectors directly from an external planet's center of mass to the Earth's core, we identify the exact geographical coordinates experiencing maximum tidal torque. This crustal puncture represents the point of peak localized strain, moving at incredible velocities. Understanding these interactions is vital for monitoring how external cosmic forces impact our planet's structural integrity and core stability in real time. The X-peak deformation globe visualizes the immense gravitational forces acting on our planet. This tidal torque is a celestial tug-of-war that generates deep internal friction. In these high-stress zones, the Earth's crust is stretched beyond its elastic limit by opposing planetary vectors. By tracking these force ripples, we can identify precise rupture points. These are the critical locations where accumulated strain is mathematically forced to breach the surface, triggering the catastrophic megathrust events we monitor. To understand planetary impact, we categorize gravitational forces into 3 distinct layers. First, the baseline tug from distant giants like Saturn creates constant chronic tectonic strain. This is compounded by variable pulses from the Moon and inner planets, which act as the rhythmic high-intensity drivers of our stress index. Finally, we must account for localized distortions from passing near-Earth objects. These flash events create hyper-localized ripples that can dangerously multiply existing baseline stress.
Between June 28th and 30th, 2026, a cluster of 4 near-Earth asteroids reaches peak alignment. While their total mass is minimal, their extreme proximity and high velocity inject unpredictable gravitational microfluctuations into our vector resultant engine. This exogenous interference requires immediate attention. These variables disrupt our standard predictive models during this critical window. We must account for these subtle yet impactful gravitational shifts to ensure the integrity and accuracy of our ongoing orbital projections.
When we examine historical baselines from the 16th and 18th centuries, a sobering pattern emerges. Saturn-Neptune alignments consistently correlate with unprecedented devastation. From the deadliest earthquake in human history in 1556 to the massive Cascadia megathrust rupture in 1700, these planetary cycles align with extreme geological instability. More critically, they mark periods of profound societal and environmental dissolution. These alignments aren't just astronomical curiosities. They represent recurring triggers for global-scale lithospheric and humanitarian crises. Our analysis confirms that the orbital mechanics of July 2026 nearly perfectly mirror the exact geometries that triggered history's most devastating tectonic shifts. By comparing Saturn-Neptune angular distances, we see similarity matches as high as 98% against events like the New Madrid shock and Kamchatka megathrust. This deep vector correlation indicates that our upcoming target window represents a period of extreme stress, signaling a high risk for major global seismic activity.
Consider the historic 1811-12 X pattern, where a rare convergence of solar eclipses and Tecumseh's comet created a perfect storm of celestial forces. This alignment generated extreme Z-axis tidal lift, combined with powerful XY-axis centrifugal pull. The resulting peak gravitational stress across the North American plate reached a critical threshold. These massive tidal interactions provide a clear framework for understanding the immense geological pressures that fundamentally reshaped our continent's seismic landscape during this era.
In the 19th century, we witnessed 2 defining examples of planetary instability. First, the New Madrid shocks demonstrated extreme intracontinental liquefaction, actually forcing the Mississippi River to flow backward. Later, the Carrington event unleashed an atmospheric fire that crippled global communications. These events aren't historical curiosities. They are the terrifying baseline for the threats we face today. As we enter solar cycle 25, understanding these precedents is vital for our upcoming 2026 planetary assessment.
Let's examine the 2025 Kamchatka megathrust cluster, a pivotal case study. In late July, an M7.44 shock unclamped the fault, setting the stage for a massive M8.8 main shock. This catastrophic event, the world's 6th largest, simultaneously triggered 7 volcanoes. Crucially, the timing coincided exactly with the Saturn-Neptune conjunction's minimum window. This correlation reinforces our baseline. Tight planetary alignments appear to be a primary driver for these high-magnitude megathrust chain reactions.
We are tracking the Kamchatka megathrust sequence, which emerged during the decline phase of the Saturn-Neptune minima. Following the massive 8.8 main shock in July 2025, gravitational models indicate the region remains in a high-energy release phase. Specifically, the Aries point alignment is subjecting the trench to extreme tangential centrifugal pull. This means the seismic threat persists into 2026 as the tectonic environment responds to intense gravitational pressures. We must remain vigilant as this sequence continues to unfold.
The July 2025 Kamchatka sequence serves as a stark precursor warning. The July 24 shock exhibited extreme productivity, with aftershocks 6 times higher than the statistical norm. This signaled a massive stress transfer that perfectly primed the rupture zone for the M8.8 main shock just 9 days later. Crucially, this sequence matches the geometric buildup projected for the 2026 planetary alignment, confirming that seismic tensions are escalating exactly as our models predicted. The 2025 anomaly has redefined our understanding of seismic risk. By re-rupturing the 1952 zone with massive slip, the Kamchatka event shattered traditional hazard models. This dynamic overshoot has created a hypersensitive environment, now primed for new stress vectors. Most concerning is the transfer of this energy toward the Americas. The Nazca plate interface is currently at peak stress, indicating an imminent and extreme rupture risk. We are entering an era of unprecedented global seismic instability. The 2025 seismic unrest at Santorini reveals a critical phase of activity. We've identified over 400 micro-earthquakes clustered at shallow depths, primarily between 0 to 2 and 5 to 12 kilometers. This swarm behavior is the mechanical signature of an evolving magmatic intrusion. Driven by external gravitational tidal forces, magmatic pumping is physically drawing magma upward. This movement triggers intense volcanotectonic crises along active fault structures, providing us with a clear baseline for the current unrest.
We must maintain close vigilance over the Santorini caldera. Currently, 310 million cubic meters of magma remain in place at depth, fundamentally altering the region's physical stability. This consolidation, combined with gravitationally induced earthquakes, creates significant stress on the underwater flanks. The primary hazard lies in the steep interior walls and the Colombo cone, which are primed for collapse. These submarine landslides pose a severe risk, potentially triggering destructive, localized tsunamis.
Our early 2025 indicators reveal significant seismic anomalies within the Santorini region. We've detected a rapid intensification in the Aegean subduction zone, highlighted by hundreds of unusual shallow earthquakes. Crucially, this upward migration of magma and hydrothermal pressure aligns perfectly with the increasing vertical tidal lift found in our gravitational models. These signatures suggest a major geological shift is underway, serving as a critical alert for our 2026 planetary assessment and future risk modeling. Mayon volcano remains at alert level 3, characterized by steady lava flows and significant sulfur dioxide emissions. While these activities are persistent, our primary concern is a shift in gravitational stress. A sudden decrease in degassing could trigger rapid overpressurization within the volcanic conduit. We are monitoring this lull before the storm closely, as it signals a high risk of transitioning from the current steady state into a devastatingly explosive Plinian eruption.
Welcome to today's Geospatial Intelligence Briefing. We have officially activated our simulation tracking Earth's gravitational landscape. Starting today, June 28th, we're launching a critical 10-day spatio-temporal forecast to monitor fluctuations in the planet's gravitational field. This data is vital for our hazard simulation, helping us identify emerging risks and predict tectonic or atmospheric shifts through July 7th. Let's dive into these early insights to see how these gravitational forces are evolving in real time. Our global hazard synthesis reveals a critical convergence of seismic, volcanic, and meteorological risks. We are currently seeing peak stress across the Cascadia and Nazca plates, alongside heightened volcanic activity in Mayon and Santorini. Most importantly, the window from June 28th to July 7th represents a rare planetary alignment not seen since 1917. This unique overlap of solar flares and tectonic pressure demands our maximum strategic readiness to ensure stability during this high-risk period. As we initiate our simulation for June 28th, we witness a profound clash of gravitational forces. The intense pull from the Jupiter and Moon alignment sharply opposes the Saturn and Neptune baseline. This cosmic conflict generates a powerful resultant vector, projecting significant tectonic strain across the Pacific Andean corridor. With an elevated stress index of 64, this opening scenario identifies a critical window where planetary positioning translates into measurable, high-intensity pressure on our planet's crust. Looking at the simulation onset for June 28th, we're seeing the first critical spikes in planetary stress accumulation. This baseline is driven by a strict celestial alignment, exerting significant gravitational pressure on our oceanic and tectonic boundaries. When we layer in exogenous variables, specifically the compounding gravitational influence of asteroids MQ2 and MN1, the results are clear. These initial vectors represent the foundational shift in global stability we must now prepare for.
Between June 30th and July 2nd, North America faces a critical window of peak continental rupture risk. This surge is driven by intense Sun-Jupiter gravitational influences, further compounded by tight Moon-Uranus alignments. While tectonic stress is rising continent-wide, the Pacific coast is reaching its maximum threshold. Consequently, we have issued elevated alerts for the San Francisco Bay fault systems and the Cascadia subduction zone. Please remain vigilant as gravitational forces reach this dangerous apex.
Gravitational stress is a dynamic force, and our latest 10-day forecast shows it's rapidly building. By synthesizing planetary vectors in NEO proximity, we've identified a compounding of tectonic pressure that cannot be ignored. While initial encounters set the trajectory, the situation intensifies significantly as we approach July 4th. The Mars-Uranus convergence will push us directly into the critical zone. We must remain vigilant as we reach this peak period of heightened spatiotemporal risk. By July 4th, our simulation reaches its absolute peak risk. Mars and Uranus converge with razor-thin precision, just 0.2 degrees apart. This rare geometric alignment focuses their combined gravitational influence into a single intense subplanetary point on Earth, completely overwhelming all baseline vectors. With the stress index hitting a peak critical 98%, we are now entering the window of maximum systemic tension. This is the definitive moment of peak global vulnerability. We are currently facing a critical window of heightened planetary vulnerability. As the Mars-Uranus vector reaches its peak intensity, its influence is compounded by the close approach of asteroid 2007 ML24. At nearly 800 meters wide, this object acts as a massive gravitational catalyst, layering an acute distortion ripple directly atop the planetary convergence zone. This rare synchronicity amplifies structural stress to dangerous levels, significantly increasing the immediate risk of a major geophysical rupture. As we enter the final phase from July 5th through the 7th, we move into the residual tail of this event. The intense Mars-Uranus alignment is now rapidly separating, causing the primary planetary tidal torque to dissipate. While two minor trailing NEOs are still being monitored, their impact remains minimal. Our stress index has dropped to 45% and continues to subside, as Earth's gravitational landscape finally stabilizes back toward the standard Saturn-Neptune baseline. From July 3rd to the 5th, we are entering a critical window for global tectonic activity. As the current planetary conjunction separates, tidal torque creates a whiplash effect, driving acute stress across the Pacific Rim. We are tracking a sharp rise in stress indices, specifically along the Nazca South American Plate interface, Japan, and the Philippines. This transfer window significantly increases the probability of major slip deficit releases, so heightened vigilance is essential during these 3 days. As we enter the terminal simulation window for July 6th and 7th, the primary stress vectors have finally dropped below the critical threshold. While this marks a significant easing of acute global pressure, we cannot lower our guard yet. Residual tidal forces continue to impact vulnerable coastlines worldwide. Despite the decreasing seismic risk, we must maintain strict coastal vigilance in specific zones still influenced by waning Moon-Jupiter vectors until this final pressure window closes.
Our simulation identifies a critical window between June 28th and July 7th, driven by a highly asymmetrical gravitational load. We are tracking significant pressure building near the Kamchatka resonance zone and along the convergence trajectory across the Americas. This stress reaches an extreme peak on July 4th. Disaster management officials must prioritize structural monitoring within these high-risk vector zones immediately. We must remain vigilant as this gravitational shift places unprecedented geological strain on these specific regions.
Welcome. Today, we're addressing the 2026 Gravitational Hazard Forecast and Global Threat Assessment. Our latest geodynamic intelligence has identified a high-risk window from July 10th through July 24th, 2026. By integrating planetary vector analysis with meteorological convergence data, we've pinpointed significant vulnerabilities in our global infrastructure. This briefing outlines the critical shifts we expect during this 14-day simulation period. It is essential that we synchronize our response strategies now to mitigate these looming planetary scale threats.
We've initiated a forensic simulation targeting the window of July 10th through July 24th, 2026. By integrating real-time Jupiter-Moon barycenter vectors against the Saturn-Neptune separation phase, we've translated complex coordinate matrices into a clear structural threat index. Our objective is precise, pinpointing the exact timing and location of forecasted magnitude 5.0 plus events. We are focusing on peak stress accumulation zones to provide an actionable executive review of global seismic risks during this critical phase.
Looking at the July 2026 window, we're tracking a rare convergence of celestial events. The alignment of Jupiter and the Moon exerts maximum gravitational torque, precisely as two asteroids pass near Earth. This overlap creates a peak in tectonic stress, specifically targeting the Guerrero-Oaxaca and Andean fault zones. With severe rupture risks and extreme vertical displacement predicted, these regions represent our most critical areas for potential large-scale seismic activity.
We have officially breached a critical threshold. Data confirms a maximum probability for a magnitude 6+ seismic event, primarily threatening the Cascadia subduction zone and the Gulf of California. From July 18th to the 21st, 2026, specific planetary dynamics and the approach of asteroid 2020 OM will create unprecedented crustal shear. This mirrors the catastrophic 1917 cycle, indicating imminent seismogenic failure. We are now in a window of peak structural risk that requires immediate executive action.
Looking at the geodynamic forecast for late July 2026, we've identified a critical instability. Although tidal torque is subsiding, Coulomb stress transfer has left the crust unclamped. This condition is compounded by the passage of asteroid 2026 KU3 on July 24th. We are specifically tracking X-peak target zones along the Mid-Atlantic Ridge and the South Sandwich Islands. Expect these focal points to trigger a series of sequential pressure releases across the globe. Looking ahead to July 2026, we are tracking a global sequence of clustered seismic events rather than a single isolated earthquake. Driven by planetary resonance, we anticipate extreme risks of magnitude 6.5 or higher hitting Kamchatka, Mexico, and the Central Andes. Simultaneously, severe activity will impact Japan and Indonesia, while volcanic risks intensify across Santorini and Iceland. We are moving toward a period of synchronized tectonic instability that requires immediate, coordinated global monitoring. As we enter this critical 30-day window, Earth is approaching its most volatile phase of planetary angular separation. Maximum tidal torque is now exerting unprecedented stress across global tectonic boundaries. Our models, calibrated against historical baselines from 1811 and 1917, indicate a high probability of significant seismic events exceeding magnitude 5.0.
From Cascadia to the Western Pacific, these high-intensity zones represent the primary migration paths of planetary-driven tectonic strain. We must remain on high alert.
Looking at the forecast through early August, our assessment indicates critical seismic activity across the Americas. In the Pacific Northwest, extreme tidal lift increases the probability of deep slip events. Simultaneously, the New Madrid zone mirrors 1811 torsional strain, placing the central U.S. at high risk for a major snapping event between August 2nd and 5th. Finally, by August 8th, southern Mexico faces a critical threshold breach, threatening a significant subduction release. Stay vigilant.
Shifting to the Pacific Rim, our mid-August forecast reveals critical seismic instability. The Kamchatka region remains fundamentally compromised following the 2025 megathrust event. We expect forces to peak around August 12th, posing a severe rupture hazard exceeding magnitude 7. Simultaneously, shifting gravitational vectors indicate a dangerous cluster of activity building between Japan and the Philippines by August 15th. We must prioritize regional readiness as these high-density seismic clusters move into their peak windows.
Between August 19th and the 30th, we are entering a critical window for Eurasia. As planetary alignments shift, gravity's echo triggers secondary tectonic snapping, threatening the Iberian and Aegean coasts with seismic risks exceeding magnitude 5. This instability coincides with severe jet stream destabilization and tectonic outgassing, driving extreme cyclonic anomalies reminiscent of the 1703 and 1917 megastorms. We are facing a dual threat period where tectonic activity and atmospheric volatility converge.
We must realize that Earth is not a closed system. History shows that devastating global events across the centuries were never random. They were terrestrial symptoms of celestial geometry. This predictable rhythm leads us directly to 2026. The Saturn-Neptune convergence provides us with the ultimate strategic advantage: foreknowledge. The gravitational vectors are already set, and the countdown has begun. Our readiness must now rise to match the absolute mathematical certainty of these planetary forces.
As we enter the August 2026 hazard window, immediate action is non-negotiable. We must first harden the Americas' power and communication grids against dual seismic and geomagnetic threats. Simultaneously, Pacific Rim civil defense must maintain heightened readiness through the August 12 X-peak window. Finally, we must buffer global supply chains against atmospheric dissolution events, including unseasonal floods and cyclonic superstorms. These strategic directives are essential for maintaining stability during this critical period of heightened planetary risk.
To safeguard our operations, we must immediately harden critical infrastructure across the Americas and Pacific Rim against escalating seismic threats. We've identified a high-risk window from July 10th through 24th. Pre-positioning assets now is vital to manage compounding multi-hazard scenarios. Looking further ahead, our strategy must evolve from tracking isolated incidents to modeling cyclical, overlapping global disruptions. The projected 2026 landscape demands a fundamental shift in how we prepare for and navigate sequential crises.
Beyond simple orbits, consider how massive celestial bodies like Jupiter and Saturn influence Earth's physical structure. By synthesizing astronomical data into directional vector forces, we see how gravitational gradients converge onto our planet's core. This process, driven by frame dragging, exerts a localized physical stress known as planetary torque. Ultimately, these orbital alignments translate into powerful tidal poles, creating a physical drag that directly impacts the movement and stability of our tectonic interfaces.
To truly understand planetary stress, we must isolate two distinct types of forces. First, the Jupiter and Moon vector acts as an acute trigger, driving rapid, high-intensity tidal poles that cause sudden, sharp stress spikes across our oceans and terrain. Conversely, the Saturn and Neptune vector provides the background tension. Operating on much longer cycles, this slow, deep resonant force gradually primes our fault lines for eventual rupture. Mastering these diagnostics is critical for accurate forecasting.
Consider the profound relationship between planetary cycles and seismic activity. We are witnessing a gravitational echo, where the Saturn-Neptune alignment of 1917 is mirroring itself perfectly in 2026. This direct correlation reveals how historical orbital distances influence modern tectonic vulnerabilities. As we approach this critical inflection point, it's clear that these cosmic patterns aren't just remnants of the past. They are precursors to significant seismic events. We must prepare for history to repeat itself.
Looking at our 10-day gravitational forecast, we are entering a period of significant volatility. While the initial resonance buildup remains stable, everything changes on day 4. This is the critical moment where the Jupiter-Moon overlap pushes stress levels past our extreme rupture threshold. We then move into an escalation phase that leads directly into sustained peak hazard warnings. We must maintain high alert status as these dangerous resonance frequencies persist through the end of our window.
In the first 3 days, we enter a critical phase of vector convergence. As gravitational poles from the Moon, Venus, and Mars align, they trigger massive tidal displacement. This shifting gravity doesn't just move the oceans, it actively distorts the planet's terrain.